Alright, thank you for tuning in to Ellensburg Amplifier Repair and Service. What I have here today is just going to be a voltage rundown, pin rundown of the Class D driver card of this is a cab 2000.1 board. This is one of my parts boards. As you can see, this board is completely intact. I purchased several of these for the items on these boards that are really hard to come by. But I realized that I wanted to do a quick video on this particular card because you don't see this card very often, but you still do find them. So having a good understanding of how this card works, what the voltages are and signals are on each pin really does help determine where the fault is if you have one on a board. So here is the driver board that we'll be talking about today. You're going to see that it's got 4 discrete transistors on each side. You're going to have your op amps in the middle. This board does have the voltage regulators. Several of them actually. You're going to have your plus minus 12, plus minus 5, plus minus 15 voltage regulators here. So you have a set here, and you're going to have a set here. These do run your preamp section here, and these two 7905, 7805, and the 7812 and 7912s do go to your driver board. So again, this is going to be a rundown of the pins. You'll see the scope in the upper left hand corner. You'll see it down in the bottom left hand corner. I have it in as a type 8 class D. So for all you that have Perry's repair tutorial, you'll know exactly what I'm talking about when I say type 8. If you don't have Perry's tutorial, I highly recommend taking a look at it. He does have a free version online, and if you're interested in getting the whole package, contact Perry and let him know what you're after. You can find him online. I think I found him back in 2018 by just searching amplifier repair. I don't know his exact website address off the top of my head, but you can also go on DIY Audio, which I'm also a member of, and you can contact Perry through there. He's a good guy. Get a hold of him. He'll treat you good. So what I'm going to do is I'm going to go ahead and fire the board up. I'm just using my 12 volt 2 amp power supply as usual. It just takes a second for the capacitors to charge. Oh, and to note, this board here, the only thing that was wrong with this board is it had 2 failed rail capacitors. Otherwise this board is 100% intact. And everything's good on it. All the drives good, all the transistors are good, nothing's burnt, nothing's shorted. So it's a good board. It's a good board to learn off of. So what we're going to have is we're going to have pin 1. Pin 1 is going to be your positive rail voltage. So this particular board is producing about 74 volts of rail voltage at 12 volts input. Pin 2 is going to be your 12 volts regulated. So if you look at the voltage on the scope, you're going to take your 74 minus your 61, and that's going to be your it should roughly come out to your 12 volts regulated, because this is all referenced to the positive rail. So that's going to be your pin 2. Pin 3 is going to be your high side drive, which, let me get my trigger up here. So there's your high side drive, which is going to be your high side drive for output to the FETs, to your output FETs. And then pin 4 is going to be your low side drive. Again, this board's going to have 2 sections of drive. So there's your low side drive for this bank here. You're going to find your negative 12 volts is what you're going to find there, which is referenced to your negative rail. Again, your 74 minus your 60 is going to give you your negative voltage. And then of course you're going to have your full negative rail voltage there, 72. So 72 minus 60 gives you your negative regulated 12 volt supply. And then you're going to have pin 7, which is your protection signal input for this bank. So then pin 8 is going to be your shutdown, which is going to be your output from this board to the power supply. So this is basically telling your power supply to shut down if there's a problem. Alright, so pin 9, you have your negative 15 volt regulated voltage referenced to ground. And then also you have your negative 5 volt regulated power. So then 11 is your the audio ground, and 12 is your audio signal, which I do have a 50 hertz signal going into the preamp. So just to show you the output signal, coming out of the inductors there for you. So the pin 12 is your audio input, and pin 13 is your positive 5 volts. And then pin 14 is going to be your positive 15 volts. And then pin 15 is the modulated output. And let me just get that on the scope here for you. So then your modulated output does swing positive and negative. It's about 5 volts from ground for your modulated output. So then 16 is going to be your protect signal for the second side of the amplifier board. And then 17 is going to be your negative rail voltage, and 18 is going to be referenced from negative rail voltage, your 12 volt supply, which is 12 volts above the negative rail. And then you're going to have your low side drive for your second bank, or channel B, whichever you prefer, is your low side drive for side B. And then you're going to have your high side drive to side B. Let me find it on my scope there for you. So there's your high side drive for your side B. And then you're going to have your 12 volt regulated voltage below your positive rail, and then you're going to have your positive rail voltage of 74 volts. So 74 volts minus your 62.5 volts gives you your roughly your 12 volt regulated voltage. And of course you can measure these with a digital multimeter from the pin referenced from your voltage regulator, if you wanted to see the the actual voltage instead of doing the math between the rail voltage. So that's the pinout for this Class D board here. So as long as you have those voltages, those drive signals, and you don't have any of your protect pins getting pulled, this board should function for you. So you'll see the negative rail on the B channel, positive, or I'm sorry, you'll see the negative drive on the B channel. You will see the B channel positive drive, and then of course you will see the output on your output terminal and you'll see that output of that 50 hertz. So that's pretty much the rundown of this amplifier. They're pretty straightforward, pretty simple. As long as you, like I said, as long as you have the voltages present, you shouldn't have any problem with these drive cards. And if you do, of course, then you just go through and you just verify all your transistors that drive this, your op amps or comparators. Otherwise, you should be good to go. Hopefully this information is helpful to people when it comes to knowing what should be on what pin and what you're looking for in case you don't have switching on your output transistors. So that pretty much covers that. I do thank you for watching. I do have a new website up, ellensburgamplifier.com. I'm working on adding parts to that, the hard to find parts, and I do have amplifiers up for sale that have been repaired. So if you like this content, please like and subscribe, share with others. I do enjoy helping others and teaching people. So thank you for watching. I will see you on the next one.